Welcome to solverfy.
In this problem, we will find the solution to the following differential equation, where A is this matrix and xt is a vector of functions on T. And to solve this problem, we will use two main steps. The first step is to find the fundamental matrix to the system xt. Then we will use this formula, the vector solution little xt is equal to capital Xt times the vector of constants with this vector is the C1, C2, and C3. Okay, so the first step to solve this problem is then to find the eigenvalues of the matrix A. So we need to find the characteristic polynomial which determines the matrix A minus R times the identity, which is the matrix, then R 0, 1, 0, 1 minus R 2, 0, 0, 1 minus R. So this is a triangular matrix. So the determinant of this matrix will be R times 1 minus R. Okay, so the eigenvalues of this matrix are given by making this system equal to 0. So we get two solutions. The first solution is this term over here equal to 0, so R is equal to 0, and the second term will be 1 minus R equal to 0, so R is equal to 1. So we also need to consider the multiplicity of each eigenvalue. For the eigenvalue R equal to 0, that comes from this term, the multiplicity is 1. Because this factor here only appears once on the characteristic polynomial. On the other hand, for the second eigenvalue, the factor 1 minus R appears twice. So therefore, the multiplicity is 2. So we need to consider this multiplicity to find the generalized eigenvectors corresponding to each eigenvalue. So the next step is then to find the eigenvectors of A. So for the first eigenvalue R equal to 0, which is of multiplicity 1, we need to find the null space of the matrix A, which is this matrix 0, 0, 1, 0, 1, 2, 0, 0, 1. So this matrix is A. This matrix is similar by operation to the matrix 1, 1, 0, 1, 0, 0, 0, 1, 0, 0, 0. So the null space of this matrix is spanned by the vector 1 equal 1, 0, 0. Okay, so for the eigenvector R equal to 1, so this is multiplicity 2 now. So we need to find the null space of the matrix A minus the identity, which is the matrix negative 1, 0, 1, 0, 0, 2, 0, 0, 0. So this is equivalent to the matrix 1, 0, 0, 0, 0, 1, 0, 0, 0. Okay, so this null space is spanned just for one vector, spanned by the vector 0, 1, 0. So this eigenvalue has multiplicity 2. So we need two generalized eigenvectors. This matrix only has one regular eigenvector. Okay, so to find a second generalized eigenvector that is not regular, then we need to look at the matrix A minus I squared. So we need to square the previous matrix. So this is the matrix 1, 0, negative 1, 0, 0, 0, 0, 0, 0. Okay, so now the null space of this matrix is spanned by two vectors, the vector 1, 0, 1, and the vector 0, 1, 0. So this vector already appeared as a regular eigenvector, so this is U2, the same regular eigenvector, and this is a new eigenvector that we find. Okay, so this will be U3, this is a generalized eigenvector. Okay, so we have then U1, U2, and now U3. So let's find the matrix xt now, since we have already the three necessary generalized eigenvectors. So this matrix is given by three columns. So we're going to write down each column by second. So each column comes from each regular or generalized eigenvector. So for the first one, x1 of t, so this column comes associated to the eigenvalue r equal to 0 and u1, because this is the eigenvector for this eigenvalue. So this will be e to the 0t times u1. Okay, so this will be the matrix, sorry, the vector, just 1, 0, 0, here. For x to the second column, this comes from r equal to 1 and u2. Okay, so this is our regular eigenvector, this u2. So this will be e to the power 1t. This one is this one over here times u2, which is et times the vector to this 1, 0, 1, 0. So it's the vector 0, et, 0. Sorry. And the next one is the third column x3t, that comes from the eigenvalue r equal to 1 and the eigenvector u3. This is a generalized eigenvector. It's not a regular one. So for this one, we need to consider something special. So this will be e to the power 1t times u3 plus t times e to the power 1t times 1 minus identity u3. So since this eigenvector comes from the matrix A minus I squared, this new term will come up here. Okay. So when we compute these, we will get the matrix Et, so the vector Et1, 0, 1 plus t times t 0, 2, 0, which will be the vector et 2 times t et et. So now let's combine these three columns together to get our answer xt. So xt will be the matrix 1, 0, 0, then will be 0, et, 0, and finally will be et, 2t, et. So this is our matrix xt. Then to find the solution, the general solution to the system, we need to multiply this matrix over here with the column vector C of constant C1, C2, and C3. Okay, so let's do this. So this will be then 100 T0 ET. So this was on the second column, but 0 ET 0 and ET 2 ET times the column vector C1, C2, C3. Okay, so the solution for this one is the vector C1 plus C3 ET, C2 ET plus 2 times C3 TET, and finally C3E. Okay, so we can also write down the solution as the following vectors. So C1 100 plus C2 0 ET 0 plus C3 ET TET 2 times TET and ET, which is the final